Hello guys, welcome to the 20th tutorial in our Pandas course. Now that we're familiar with how to modify data frames in some ways by adding elements, removing elements, or modifying elements, we're going to talk about some other kinds of operations we can perform here. For starters, we'll talk about arithmetic operations. Those will be your basic addition, subtraction, multiplication, division, etc. Then we can talk about how to apply functions to data frames to change values in interesting ways. Then we'll talk about how to transpose data frames. It'll be a very simple operation that just flips rows and columns. Next up, we'll talk about how to convert data frames to different types, and we'll finish off with sorting data frames. Now, a lot of this functionality will be very similar to the series functionality. Mostly the addition is that we have different axes to work with, so that's always something that we can add in. Likely, we'll try to get through things fairly quickly and fit it all into one section. So let's head on over to the code and get started. Alright, so we left off last time in section 19 by modifying and restructuring data frames. We're going to get a new cell up and running, and I think we're just going to steal off this data frame that we used previously. So again, this is what it's going to look like. I'll just print it out along with those dotted lines. And this is what it looks like. Okay, so we have some columns, some rows, etc. Okay, it would help to have, again, at least a few columns and at least a few rows. That way we'll get the most out of the functions that we'll apply. Okay, so your basic arithmetic operations first. Now, again, we can basically use the simple operators, arithmetic, simple operators such as the plus, minus, multiply, divide, floor division, modulus, and the exponentiation operator. Okay, so we can either do that, or we can call upon the specific add, multiply, etc. functions that are inherent to pandas. So I'll demonstrate just one or two examples of each. Let's say we want to add 5 to each of the numbers in our data frame. Simple enough. All we'll do is data frame plus 5. Okay, so it's going to take every single value it finds in the data frame regardless of row or column, and it's going to add 5 to it. Now, this will return a new data frame. In fact, almost all of these operations are going to return a new data frame rather than modifying the original. So it will store the results in some other data frame. Let's call this, let's just call this result. Okay, data frame plus 5, and we can print off result here. Okay, so as you can see, every element, except for, of course, the not the numbers, makes sense, has had 5 added to it. Similarly, let's say we wanted to multiply or let's say we wanted to square everything. Okay, we could do df to the power of 2. Okay, and then again, print out the result, and you can see that everything is squared now. You can apply that same logic to any of the arithmetic operators. Alternatively, and perhaps the better way of doing things, is by using the built-in functions. So let's say I wanted to, again, add 5 to everything. I could say df.add. Okay, and then I can put in my the value that I'm trying to add, but you can see that I also have additional parameters. We're not going to worry about level, but the ones I'm interested in are going to be the fill value and the axis levels, or axis parameters rather. This way we can specify exactly which columns we want to perform these operations on, or whether we want to perform them across rows. And then we can pass in a value for the not numbers. I'm not going to worry so much about the columns here. You can read up on it here. And the reason I'm ignoring it is because we actually do want to apply these operations across the entire data frame at this point in time, but I am interested in the fill value. So let's say again I want to add 5, but I want to change all these not numbers to 0 and then add 5. Okay, so for that I'm just going to add in my fill value parameter, and we're just going to do a 0 there. So this will ensure that all my numbers get converted to zeros first, and then it will add 5 to everything. Okay, so let's just store this into result and take a look. The end result should be exactly the same, okay, except of course the not numbers, they'll have a value of 5 in this case. So you can also call upon subtract, multiply, divide, square. I think there is a floor division and modulus operators in there as well. They all do exactly the same thing. Okay, so that's your arithmetic operators. The next thing I wanted to talk about is going to be the function operator. So this allows us to create a function and pass it into a data frame. So let's take again that example of y equals mx plus b. I think that's a good function to create, a good example. So this will be applying functions. And we're just going to create a function. It's going to just be called f, I suppose, and it's going to take in just an x value. Okay, we don't actually need x and y, interestingly enough. We only need an x because it just needs one input. Okay, that's all it needs is an input, and that input is just going to be the element that it's currently on. Remember, this function will be applied to every element, so it's just going to take in the current element it's working with. Okay, so we're just going to return we'll just return mx plus b. We could do like maybe a slope of 2. Okay, so we do 2 times x. I'm just going to put these in parentheses for kind of ease of readability. And then we're going to add, I don't know, maybe 5 to it. Okay, we can have a y-intercept of 5. Okay, so fairly straightforward stuff. Okay, so we have our function. In order to apply this, all we need to do is do df.apply, oops, not Apple, we want df.apply, and then the function that we want, in this case f, and that's it. Once more, this is going to spit out a new data frame, so we're going to store the results in result. We can go ahead and run this, and you can see that this function is being applied to everything. Of course, it's not being applied to not a numbers. If we wanted to do that, we would probably have to do something like fill NA, and then apply the function. It doesn't actually have a fill value parameter like with these basic addition, subtraction, multiplication, division, etc. Okay? Alternatively, you can also use the transform function, but the transform function I find is better suited to the built-in functions that are part of I guess either part of the NumPy or the Pandas library specifically. There's no real noticeable benefit, especially if you're just starting out with Pandas, as if you're going to apply a function this way versus using the transform function, but you know, it's not really something that we need to worry about when to use this versus when to use that. We will, however, just demonstrate exactly what it does, df.transform. Okay, and then we can basically pass in a function. So again, going to take in a function, going to take in the axis if we want to apply that. It's just a bit more restrictive, I suppose. Okay, now this is pretty interesting because there's a variety of ways in which we can apply various functions. For example, let's say I wanted to square everything in my data frame. Okay, so we saw what that looks like. df squared, we can do that. We can also use the np square function, so np.square. Okay, this is going to take the NumPy's version of the square function, which does again exactly the same. Well, the end results should be exactly the same, and you can see that we get everything squared. Okay, so we can pass in something like that, just like we would with an f. We can also pass in our f function, by the way, and that also works through transform. Like I said, for our sakes and purposes, there's no real difference between the two. We can also pass in functions via strings. So interestingly enough, Pandas is smart enough to know that when we pass in square as a string, we're trying to use a square function. Actually, you know what? I should probably document each of these. So square, the first thing we did was np.square. And the second thing that we did was just the f. Okay. Alternatively, we can also pass in a lambda function. So if we want to create our own custom square function, we can pass in a lambda x squared. Okay, this will again do exactly the same thing. By passing in a lambda function, it's as if we're doing this inside of the brackets already. Okay, in fact, if we wanted to do exactly that, we would do lambda x, and then we would do this. Okay, it's exactly the same thing. It's just if we have a lot of functionality, we should probably put it in a separate function. If we have just a little bit of functionality, then we can do this easily enough. But again, you should see the results exactly the same. We're just squaring everything once more. Now, one of the benefits of using transform is that we can apply multiple functions simultaneously. So this is really cool. Let's say we wanted to square everything, and then we wanted to take the log of everything. I'm not sure why we'd want to perform those operations in that order, but let's just say for whatever reason we did want to do that. Okay, for this, we're actually just going to pass in these functions as a list. Okay, so it's going to perform first one, and as in the function that is in the list first, and then the other one. So for example, let's say I want to do an np.square, square, okay, and then I want to do an np.log. Okay, now this is actually going to apply this to all columns, and it will perform the operations all at the same time. Let's go ahead and run that. And now here's where things start to get a little bit different. Okay, we're actually creating, because we're returning a new data frame, remember, we're not modifying the original one. You can see that we have our basic column 1, 2, and 3, but each one has been divided into these sub-columns with the square results and then the log results. So essentially what we're doing is we're applying this operation, putting it in this column, and then we're applying this operation and putting in this column, in the second column. So it's actually doing this at the same time. What it's not doing is performing the square on a number and then taking the log of it. It's actually performing the square, putting it in that column, and then the log and putting it in the other column. Now, interestingly enough, this is actually the natural log. So if you're kind of trying to do like a log base 10 and wondering why you're getting different numbers, that's why this is the log base E. Okay, so this is the natural log. Okay, so this is great if we want to perform various operations and compare the figures kind of after each of the operations there. It will create a separate subcolumn for each operation it's performing. Now, the final thing I want to cover with regards to the transform function is that we can actually apply the transform to specific columns using a dictionary. So we can do tf.transform. Okay, and let's say I want to again do the same thing. I want to do square and then log, but I want to do this to specific columns. Okay, so let's say column 1, I want to apply the square. So np.square. Okay, and then for column 2, I want to apply the log. So np.log. Okay, then I want to go ahead and print those out. So it's actually going to return me a data frame with just these columns specified because I'm only operating on those, and then of course the respective functions. So I'll take the squares here, and then it will take the logs here. And note how, again, it doesn't throw us any errors for not the numbers, it just doesn't really perform the operations on them. Okay, cool stuff. So that's all I really want to cover with regards to the transform. There is a lot more functionality when it comes to the transform and apply functions, but really we could devote probably a whole hour into just talking about those, and I think it's a bit impractical. Definitely recommend that you check up on these and explore these some more though. Okay, the next thing I want to talk about is transposing. So this is a really easy operation. It's just using one function. We can do something like df.transpose, okay? And this essentially just flips our rows and columns. So this is very useful if you have, you've read some data and then you realize, oh, all my row indexes should actually be column indexes and vice versa. You can just call on this function and it just flips everything in place. So it keeps the same labels. For example, this is row 1, column 1. This is column 3, row 1, so column 3, row 1. It will keep everything in the exact same index labels and order. It just flips our rows and columns, okay? So row 1, 2, 3, and 4, and then column 1, 2, and 3. Okay, very useful little operation there. Okay, so the next two things I want to talk about is type casting, so changing the type of your data frames and then sorting things. So I'll just actually make a note that this is the transpose. Okay, next up is the type casting. Okay, and this is really exactly the same as with series. We just say the data frame .as type and then enter the type that we want. For example, these are all, let's say these are all not a numbers and floats. It doesn't really make much sense to try to convert a not a number to an integer. That's not really going to work. So let's say we want to convert these all to objects. Okay, so in that case, I can say object, okay, and we're just going to print off the results there, and this is actually going to return a result, okay, and you can see this is making them all objects. They no longer are float values. Or if you want to convert them to maybe a specific type of float, like a float 16 or something, you can do that. Again, you can pass in the string if you want, or once more you can pass in like an np .float 16 or something. Okay, doesn't really matter. The results will be exactly the same whether you use the string representation or the NP representation. Just note that this is being applied across the entire data frame. So regardless of which rows or columns are of which types, it's going to cast all of them into this single type. Okay, that is again important to note because a data frame can contain columns of multiple different types. For example, we could have a column that's just objects, column that's floats, column that's ints, and so on and so forth. Okay, so the last thing I wanted to talk about here is going to be sorting. Sorting works in pretty much exactly the same way as with series, with one major difference, and that is that we can sort by column or by row, whereas with series we were just sorting essentially the one along the one axis. So this will also return a result, so we're just going to store it in a variable called result. It will be a new data frame, and we can sort by index or by values. So let's try sorting by index first. In fact, everything is already in order. Perhaps I should mix it up a bit. Let's do column 2, column 1, and we'll, let's do column 3 and then column 1. Okay, so just so things are in different order there. Okay, so let's say we want to sort by index, okay? And we'll say ascending is equal to either true or false. So false if we want things from greatest to least, and true if we want things from least to greatest. Okay. We can also specify the axis. That should probably come first, actually. Axis equal to, again, either 1 or 0. 1 will sort by rows, 0 will sort by columns. So actually, let's just explore both. You can leave ascending true or false, totally up to you. Okay, so this is the result. You can see, again, greatest to least, because row 4, then 3, then 2, then 1. Okay, and this is sorting by the rows. Or rather, it's sorting the rows. Okay, so we get our rows from 4, 3, 2, and 1. If we want to sort by columns, we can do axis equal to 1. Okay, and then we're going to get the same thing. Greatest to least again, 3, 2, and then 1 there. Similarly, we can sort by values. Now, this actually does work a bit differently because we need to specify how we want to sort things. Okay, the reason we need to do this is because different rows and different columns might have the largest or smallest values in completely different indexes. So let's say our column 1, for example, has a greatest value at the first row. Column 3, however, has its greatest value at the third row. So which do we sort first? Do we do row 1 first, row 3 first? Well, that's up to us to specify. So we're going to call the sort values function, and we're going to pass in which column we want to sort by. Okay, so actually you can see in the documentation here, by is going to be a list or a list of strings. Rather a string or a list of strings, and then we can either choose by row or column depending on the axis that we want. We can also specify which kind of algorithm we want, but we're not going to get into that one now because we've already kind of covered that. Okay, so let's say we want to sort by by the way, this could also be column or row, depending on which axis you're choosing. You do need to be specific because if you try to do a column label and then pass in the row axis, that's not going to work because that label doesn't exist on a row. Okay, so for example, let's say I want to sort by columns, which will be an axis of 0. So in that case, I'll be explicit with the axis labels. I'll say I want to sort my values by column 3. Okay, and I want axis to be equal to 0. Okay, so this is going to sort my values again from least to greatest because I said ascending is not equal to false. So I could do ascending equal to false. That will give me, let's do ascending equal to false so we get greatest to least. Okay, so you can see 9, 4, 9, 6, 4, and then not a number. So not a number, again, it can't really be the greatest or the least. So it's just it's always going to be last because, again, can't be greatest or least. Okay, so you can see that things are being sorted by column 3. So the top number in column 1 is not the 10. But again, we're sorting by column 3 and we have to keep the row elements the same. Okay, so we can't just sort column 3 and leave the other two unsorted. We have to kind of sort the entire thing based on the values in column 3. So that's kind of how it's going to work. Similarly, we can sort across rows. So let's say I wanted to sort by row, let's say row 2 here. Okay, this time I need to specify my axis of 1 because otherwise it's going to look for a column label of row 2 and that doesn't exist. So I'll do ascending false again. And as you can see, I'm taking my row 2 and I'm using that from greatest to least. Okay. Note that I'm also not shuffling the order of my rows. I'm keeping the rows exactly as they are. I'm just shuffling the columns around. Okay. So take greatest value in row 2, then the second, and then the third. Okay. So those are the big differences between sourcing with data frames and with Pandas series. With data frames, we need to specify the column or the row in which we're sorting and then the appropriate axis. Or if you're just sorting by index, you need to specify which axis you want to sort by because, again, with two-dimensional data, it's kind of harder to sort unless you specify these things because we don't know which index to sort by. Okay, so that's pretty much it. Let's just quickly recap here. We started with the basic arithmetic operations, then we moved to applying functions across all of the elements in a data frame. We talked about how to use various built-in functions and the transform pandas function. We talked about transposing here, then how to cast two different types, and then finally how to sort by index or value. Okay, so definitely give this stuff some practice, especially some of the other arithmetic operations. Definitely research some more about transforming and applying if you can. And once you're ready to move on, we'll talk about data frame comparisons and iterations. So stay tuned for that. Thanks for watching, and see you guys in the next one.